Okay, two things to write down, one example. First is the linear factorization theorem. It has like this big fancy name, right? But I feel the concept of this big fancy named theorem is super straightforward. Yes, you remember what it is?
Maybe depends. It says factorization of linears, so.
If we have polynomial degree n, n tells us what?
Oh.
It is the exponent. What else does it tell us? Okay, how many turns we're gonna have? We talked about that. Okay. Okay, we have n zeros and n. What did you say, guys? Yeah. Okay. We have n zeros and n linear factors. Didn't even have to tell you. We could figure it out. Okay. Linear factor, that means like x minus k, right? So no matter the polynomial, we can find n zeros and we can write it as n factors. Now, some of the zeros might be imaginary. Some of them might be real. Some of them might be rational. Some of them might be irrational. Okay, but there are n zeros. And with those n zeros, we can write n factors. Okay. That's something we'll work a lot with next week when we get to our rational zeros test, you know, the P's and Q's and all that stuff. Don't worry about it till Monday. Okay? What I want to talk about today are the imaginary zeros. Okay? I want to talk about the imaginary zeros. We mentioned yesterday that if we have imaginary zeros, our curve is not going to cross the x-axis. Okay? It satisfies the equation, but we don't cross the x-axis. Okay? What we need to understand about imaginary zeros or complex, they are always going to come in conjugate pairs. If a plus bi is a 0, a minus bi is also a 0. No matter what. If a plus bi is a 0, a minus bi is a 0. Why do you think that is?
Because you square root something, and you don't know if the square root would be positive or negative.
Okay, so you're kind of thinking of like the quadratic formula, right? Where we have like that plus or minus with the square root.
Sure.
Or when we're solving from both sides, like we have x squared equals negative 4. Is that what you're thinking?
Yes.
Okay. You're not wrong. Okay, guys struggling back there the same way. But, you know, if you think about the quadratic formula, we have that plus or minus. Okay, that's like forcing us to have conjugate pairs. Okay. X squared equals negative 4, right? We square root both sides, we're getting the plus or minus. Okay? But what happens when we multiply conjugate pairs? Yeah, what'd you say? Sorry.
No, I didn't know.
You were excited, you was raising your hand. It's totally fine. Okay, we get that real number, right? The i's go away. Okay? We need those conjugate pairs so that our polynomial has real numbers in it. Okay? So, our one example. This is what your homework's going to be like. All right? I want us to write a 4th degree polynomial with zeros 1, negative 2, and 3i. 1, negative 2, and 3i. How many zeros should there be? 4. 4. Because it's a 4th degree polynomial, but I gave you 3.
But the 3i has 2.
We have an imaginary 0. They come in conjugate pairs. So if 0 plus 3i is a 0,
0
then
minus.
also 0 minus 3i is also a 0. Okay. So if I want just the linear factors of our polynomial, then we would write x minus 1, x minus negative 2, x minus 3i, and x minus negative 3i. There is our polynomial. What if I ask you to multiply it out? That's what you're doing?
Alright.
Okay. I'm gonna ask you to hold on tight. Okay? So I'm gonna talk about the steps that we need to take. Gabe, which two should we probably multiply together first?
X minus I, 3i, and x plus 3.
Okay, we know that this is special right here, right? Multiply those together first. So we get x squared plus 3ix minus 3ix minus 9i squared.
C.
Okay. So we get x squared plus 9. Okay. Now let's work smarter, not harder. Okay. We know we are going to have to multiply that to x plus 2, and we know that this is being multiplied to x plus 1 and x minus 1. Okay. Instead of like doing one multiplication at a time, can I multiply these two together?
Yes.
Yeah, we can. X squared plus 2x minus x minus 2. Okay, so I have 4 factors. I multiplied these two together, I multiplied these two together, and then we can take the result and multiply those together. So this becomes x squared plus x minus 2. Now we only have to worry about one multiplication that is not binomial times binomial. Okay, go ahead and work on that for me. Is this what you're getting?
Yep.
If you're not, have a neighbor look at your work and see where the mismultiplication happened.
Oh, what's your first? Well, it might have been.
It probably was.
I spent $30
You wanna leave it like that? Alright, are we getting it here?
Yes.
Your 2 homework problems are exactly like that.
Oh no.
Yes.
No hidden tricks. Can you handle it?
Yes.
Okay. Alright, go and get ready for your quiz.
Is this all our quiz?
Nope.